If we want to look at an application problem where we'd be graphing, it's really not that uncommon that we might end up with three or more systems of three or more inequalities in a particular system. You can see in this instance we're saying that Maurice can invest up to $50,000 between two accounts. We're calling them the amounts C and T. This gives us this inequality: C plus T is equal to 50,000. If he's placing at least $10,000 in treasury notes, that means T should be at least $10,000, greater than or equal to $10,000, and no more than $35,000 in corporate bonds. So C should be less than or equal to $35,000. You can see how each time we say up to, or at least, or no more than, these each translated into their own inequality. If I wanted to graph this system, then I would probably restrict myself to just the first quadrant, because we're only dealing with, it's not possible to deal with negative amounts of money invested in an account. And I would just want to make sure that my scale here is large enough. Of course, my usual thing of just counting up to 5 isn't going to work here. So let's take a moment and say, well, what are my intercepts of this one? This one will go through the points. If C, I should probably label my axes. Let's call this the C-axis and this the T-axis. Since I don't have x's and y's, I kind of need to be explicit in what they mean. So if C is 0, then T would have to be $50,000 or 50,000. This is looking at the equation, so pretending that's an equal sign for a moment. One of the intercepts would be 0, 50,000. If T was 0, then the other number would have to be 50,000. So we get 50,000 comma 0. So I know right off the bat that these axes need to go up to 50,000 at least. This one right here, C equals 35,000. Well, this is just like saying x equals a certain number. This is a vertical line, because C is my horizontal axis here, and if I'm saying C is set, that means I know exactly my horizontal position, so it's going to be somewhere along there. Also, that's 35,000. If I go up to 50,000 here, then that 35,000 is going to be included. This one here is horizontal. Through a similar reasoning, if we know where we're at on the t-axis, that means we know height, so we're somewhere along here. So let's go ahead and draw the scale in. 1, 2, 3, 4, 5. So this is 50,000. But of course, this would then have to be 10,000. 1, 2, 3, 4, 5. That's 50,000. And this is 10,000. Okay, so my first inequality, like I said, I have the point 50,000, 0, 50,000, and 50,000, 0. It is a solid line because this is a non-strict inequality. And I'll just kind of freehand this in there. That kind of worked. A little bit off, but it's pretty close. That's my first inequality. And figuring out which way I would shade here, I didn't leave myself enough room. Test the origin with the first inequality. 0 plus 0 is less than or equal to 50,000. That's a true statement, so we would shade toward the origin there. If we didn't invest any money in anything, I wouldn't have more than $50,000 invested here, so that makes sense. The second line, C should be less than or equal to 35,000. Well, 10, 20, 30. 35,000 is right here. And like I said, this is a vertical line, so our line looks something like this. Let me redraw that. Nice thing about doing this digitally is I can just undo. The origin, if we want to test this with 2, testing the origin with line 2, I get 0 is less than or equal to 35,000. That's a true statement. So the origin satisfies this inequality as well, so I'll shade on that side of that line. And this third one, T should be greater than or equal to 10,000. That's this right here. That's my third inequality. And testing the origin with third line, that says 0 is greater than or equal to $10,000. And that one's false. So this means we should shade on the other side of the line, which is above the line for this one. Now, you might take a couple seconds to think about which region satisfies all three inequalities here. And you could then see that this region right here is on the correct side of all three of those lines. Notice I'm not crossing over any lines when I'm doing my shading here. Alright, the follow-up question here says, can Maurice put $20,000 in corporate bonds and $30,000 in treasury notes? Well, this is the point 20, 20,000, 30,000. That's that point right there, it looks like. Actually, I guess that might be right on the line. Trying to read that off the graph might be a little sketchy, so we might test each of these inequalities individually. C is $20,000 plus 30,000 is less than or equal to 50,000. This is a question mark. That one's true. That's actually equal to $50,000, so it actually did lie right on that line. We want C to be less than $35,000. C was the amount in corporate bonds, so we want $20,000 to be less than or equal to $35,000. And that's true as well. It is to the left of line 2. And lastly, we want T to be greater than $10,000, so we want $30,000 to be greater than or equal to the question mark $10,000. That is true, and you can see that shows that this point is above line 3. So all three inequalities are satisfied, and you can see we're on the correct side of both of these lines. The only thing I didn't really talk about is that the fact that we're on the line, directly on the line, the only reason we satisfy this inequality is because it's a non-strict inequality. It says the less than or equal to. It's the or equal to part that allows it to be true there. So can he do that? Yes.